Stanford University.
All right, let's get started. Welcome to Lecture 12, CS193P. Today is, I think, a very exciting lecture. We're going to get into two new pieces of the APIs that will add a lot visually to your apps. So one of them is Webviews, and the other is Maps. Right? Maps is new to the 3.0 SDK, so those of you watching at home, you'll get a lot out of this if you watched the last class. But yeah, we'll take you through how to add these to your app, and there's a couple fun examples that we'll take you through as well. First, some announcements. First things first, Paparazzi 3 is due next Wednesday at 11:59 p.m. We'll be posting it tonight on the website, so take a look. Everybody do okay with Paparazzi 2? Everybody's core data masters now, right? Hopefully you got through it. If you're still struggling with it, send us questions as soon as you can. Paparazzi 3 is, you're not going to have to get any deeper into the core data stuff than you did in number 2, but we are introducing some new concepts in this one, so I would encourage you to get started early again. So next thing I want to bring up is final project proposals. It's already that time of the year. We're already thinking about the end of the term. Final project proposals are due next Wednesday. Details are on the website. Go check it out. In a nutshell, we're allowing you to work in teams of 1 or 2, or alone or in a team of 2, I believe is the max. You come up with your own idea, and you have 3 to 4 weeks to implement it. We would like you to come up with a proposal ahead of time. You have to come up with a proposal ahead of time. Send to us. We'll review it and tell you if we agree that it's the right scope. We want to make sure you're not working too hard on it. We want to make sure you're not trying to do something that's too easy. Also, if anybody's looking for ideas, we've had a lot of third-party, a lot of companies and even professors at Stanford that have come to us and said, hey, we would really like to have one of your students build an app for us. And there's all kinds of interesting stuff in all kinds of different departments. So if you're looking for ideas, come to us, send us an email. We will try and match you up with something. We'll give you a list of what we've been contacted with, and you can pick and choose from that list. So, Okay, so the last thing I want to bring up here is Friday's lecture. So tomorrow's lecture. We have Evan Dahl coming to speak to us, and Josh mentioned this on Tuesday. Evan used to teach this class last term. He used to be an Apple employee, and he's since spun out on his own and is building applications for iPhone and iPad as well. He has a lot of thoughts about where these devices are headed, what the opportunities are and potential are for these things. So if you want to go listen to a talk like that, I would highly encourage it. He's a great speaker. So yeah, that's Friday. It's tomorrow, 4 p.m. And of course, we'll be taping that as well. Today's topics. All right, so we're going to get into first UI Webview, how to embed the web into the whole internet into your application, which is surprisingly easy. We'll show you how to load URLs and load HTML into a web view, and we'll show you how to navigate. We'll show you how to navigate the web view, so back and forward. We'll talk about CoreLocation. And then complementary to that, we'll talk about MapKit, so how to embed maps into your application as well. And we'll talk about how to add pins to it and how to look up locations from addresses. Look up addresses from locations. All that coming up and more. So UI Web Views. First things first. How to display web content. Well, UI Web View is the class that UIKit provides, and it's basically a WebKit. If you haven't heard of WebKit, WebKit is an open source framework, library that Apple started several years ago. And it's not just limited to Apple. There are several companies that have adopted it for their browsers, particularly in the mobile space. It's very performant. It's easy to use from an API perspective. Even a lot of the competitor products are using WebKit as their engine for rendering HTML. So that's what's under the hood. When you use a UI web view, you have a few ways that you can load stuff into that web view. The first, and actually that's the last one on the list. You can take an HTML string, right? So if you format an HTML string locally, you can stuff that into the UI web view, and it will format it for display. If you have raw data and a MIME type, so let's say you have a PDF, you have the data for a PDF and you know it's a PDF, you can feed that into a web view as well, and it'll render that PDF for you and give you all of the same PDF viewing experience that you get on the phone. So scrolling, it'll, there'll be, all the pages will be there, and there's a whole bunch of different MIME types that it supports. I think Keynote documents as well. Maybe not for free. It does? Okay, sweet, it does. Anyway, and the last one, yeah.
What is a MIME type?
MIME type is, it's an internet type. I mean, I don't really know. No, it's a code to identify different types of data, right? So different image types have MIME types that are associated with them. Different file types have MIME types associated with them. Yeah.
It stands for Multi-Purpose Internet Mail Extensions.
MIME type stands for Multi-Purpose Internet Mail Extensions. Is that right?
That's what it says in Wikipedia. It's
That's
gotta be true.
Wikipedia is always right. So anyway, the last way of loading a data into a UI web view, and probably the most common, is by using a remote URL. So if you have http://www.stanford.edu, you can turn that into a request, stuff that into a web view, and very few lines of code, you can load that into your app. Again, it leverages WebKit, so you don't get access to all of the WebKit functionality by going through UI WebView. It does it adds a layer in between for obvious reasons. It does make it easier, for that matter, for doing things like loading and navigation. And there are delegate methods on the UI web view for doing some control. For example, if you wanted to prevent a user from pursuing a link, you can actually stop that using one of the delegate methods. And we'll show that in a little bit. It also lets you run JavaScript code. And for safety purpose on the device, what it does is it limits JavaScript execution to 5 seconds of execution continuous and 10 megabytes of memory. And that's the iPhone OS trying to prevent rogue JavaScript functions from taking over your device. So pretty useful. You're fine with that. 5 seconds to execute a script. If you can't do it, it's a bad script. Okay, so let's look at UI web view. It's a subclass of UI view, so you use it like every other UI view you've included in your app so far. The 3 ways that we've talked about for feeding it data, the first is load HTML string, and that's where you give it a formatted HTML string. And base URL, which you can pass in nil if your HTML is complete. You can give it load data. So in the PDF example, you could feed it the NS data that corresponds to the PDF on disk, and you give it the MIME type for the PDF. Or you can give it a URL request, and it's just one parameter. It takes the NS URL request, which I'll show you in a minute, which I think you might have already seen, the NS URL request. It's no, okay. Anyway, it basically takes a URL, packages it up, does all the communication for you, and yeah, that's what you feed it. Oh, look at that. Encapsulates a URL to load and the caching policy for fetch data. So UI web view, here are some of the properties on it. First, you can ask it if it's loading. You can ask it if it can go back. So are there any web pages in the history? You can ask it if it can go forward. So if you're on the most recent page, that's going to return no. If you've stepped back a couple times, then that's going to return yes. And there are a few methods on there as well. And you should be familiar with these from using web browsers, which I'm sure you've all used. Reload, stop loading, go back, and go forward. And a couple others that are pretty cool. Scales page to fit is a settable property. If you set to yes, that UI web view is going to take whatever it loads, whatever web content it loads, and scale it down to fit within the bounds of your web view. So if you load a web page like New York Times, right? It's probably pretty wide, too wide to fit on the phone. When you set scales page to fit to yes, it actually takes it down and zooms it out so that it fits within the 320 or whatever size your web view is. And actually another one, detects phone numbers, is pretty cool. If you set that to yes, it actually scans the text. And if it recognizes what it thinks is a phone number, so in the US that would be parentheses, area code, and a 7-digit number with a dash, it knows it's a phone number. It does international stuff as well. It'll turn that into a link, and if the user went and clicked on it, it would actually ask them if they wanted to make the phone call. So yeah, let's wait for the demo. There's a delegate. You can set yourself as a delegate of UI WebView, and you can ask a few things. You can get a few things from that. So you can find out when the WebView is going to start loading. You can find out when it's done loading. That might be useful for, let's say, putting up a spinner, right, to show you that progress is happening. You can find out if the load failed. So let's say internet's out or the site's down. You'll actually get called back with a did fail load with error on your delegate. And the last one, which we'll actually take a look at in a demo, is WebView should start load with request navigation type. And you'll notice it returns a Boolean. And on your WebView, anytime somebody fills out a form or clicks a link, that will get called and give you an opportunity to do something different. If you return yes, it's going to continue and actually load the URL. If you return no, it's going to block it. So you have some navigation options there. And that UI WebView navigation type enum is actually what defines whether it's a link or a form that the user is trying to get through. Let's do a demo. And this one's particularly cool, I think. When I first saw it, I was pretty impressed, which is we're going to make a simple web browser with about 3 lines of code. So let's go into Xcode here. Let's hide these. All right. So I'm going to create a new project here. And we're going to just say, we're going to just do a view-based application. All right. And we're going to call this simple browser. OK, so of course, if I run it, it's just going to be a gray screen. There's nothing special there. What I'm going to do is I'm going to open up the nib for the view controller that it automatically created for us. And I'm going to set it up with a web view. So here it is. It's hiding behind this little library. All right, so let's do this. Let's put in a toolbar right up at the top. And we're going to put a web view below it. You'll see it's this little guy over here. It has the Safari logo on it, the little compass arrow. So we're going to pull that in. And let's resize that. What's that? My toolbar goes on the top. Josh made a good point, which is that toolbars are supposed to go on the bottom. But for the purpose of this demo, I'm putting it at the top. But I'm no HI expert either. OK, so our toolbar right now has 1 button. I'm going to change the style. And I'm going to, again, I'm no HI guy, so I'm going to reuse the rewind button as a back button. Don't try this at home, kids. OK, I'm going to take another button here. And I'm going to use the fast forward button as a next button. How's this for reuse? All right, let's take a text view. Oh, not that one. Text field. And we're going to stick that in there. And we're going to put another button. And we're going to use the refresh identifier, which conveniently looks like a reload button. Let me make this a little wider so it's prettier. All right, so this is our nib, right? We have a web view. We have a toolbar with a bunch of buttons and a text field where you could probably guess we're going to use for URL entry. Now, before I hook anything up, let's make sure that our view controller has the right IB outlets. All right, so it's the simple browser view controller. Let's make this a little bigger. We're going to add 1 IB outlet, which is the UI WebView. And because we're responding, if you remember from Brad's talk on Tuesday, we're going to respond to the text field. So we need to be a delegate, UI text field delegate. All right, that will allow our simple browser view controller to listen to, it'll just confirm that it responds to those methods. So let's do that. Let's hook this up. So back to our nib, if I'm going to hook up the outlet of our files owner, our view controller, to point to the web view. So web view. And I'm going to take this text field and have it point to, excuse me. You have to click a couple times when it's embedded in these things. We're going to take this text view and we're going to point it back to our view controller and set it as the delegate. Now, while we're in here, let's take a look at UI WebView and some of the properties that we have. You've seen this already in the slides. There's a scales page to fit. I want to turn this on. There's a detects phone numbers, which is already on. There's a detects link, which if somebody just wrote plain text, http:// whatever, it would actually turn that into a link even if they didn't do the right thing in the web page to make it an ahref. But let's just turn on scales page to fit. Now back to our code. I'm going to implement one of the text view delegate methods, which is the text. Oh, it actually returns a bool, and its text field should return. Okay. Now in here, so the workflow is this. You type in something to the text field. We're going to turn that into a URL. We're going to turn that into a URL request, and we're going to tell the web view to load. So let's go ahead. We're going to say NSURL, URL equals NSURL, URL with string, text field.text. We're going to create an NSURL request, which again is the what does the caching for you and is used for requesting off a web view. So request equals NSURL request, request with URL. If I was a good programmer, instead of using these convenience methods, I would do alloc init and then dealloc, but for today, we're just going to do this. Web view, load request, right? And because we're good citizens, there's nothing else implemented here. We go down to our dealloc, and we make sure that we clear out our IB outlet, which is the web view. All right. So 3 lines of code and a release, maybe 5, 6 lines of code if you count the parentheses and this thing. So let's hit run. And there we go. Before I do that, we never hooked up the buttons. So let's do that. If we look at UI WebView and we go to the second tab, you notice there's a few actions that are already defined on it. So I'm just going to hook these buttons straight up to that. So our back button is going to set up the go back on the web view. Our forward button is going to be go forward. Our reload is going to be reload. And there's no stop. Let's hit run. All right, so there's nothing there. If I type in, let's say, Stanford, and I hit return, there's our Stanford. If I then go and type Apple, that loads up Apple, right? I can hit the back button, goes back to Stanford. I hit the forward button, goes back to Apple. I can hit the reload button as many times as we want, and that iPad is never going away. So that's a web view in 3 lines or less. Okay, so the next thing, actually another demo I'm going to show you, is web views aren't just used for loading requests from the web. You can actually use them for doing rich text. On the Mac, there's a type called NS attributed string, which allows you to embed formatted text. So you can say normal NS string that you're all familiar with is just a string of characters. NS attributed string allows you to say that this area should be bold, and this area should be larger, and this area should have this font. We don't have that on the phone. So what people do when they want to do more rich text rendering is use UI Webview. I mean, clearly, the WebKit does all kinds of rich text rendering, so we're going to use that for this purpose, and including embedding links. So I'm going to go to a demo I set up earlier, which actually includes this same class that we just created, a little richer down here. So web and maps. Where's our project file? All right, so here's what I have. Let's look at our nib really quick. So if I go into main window, we have a tab bar controller that's hidden behind this with 3 tabs. All right, the first tab, I'll show you a little bit about what I did to the example that we just talked about. I enriched it a little bit, but we're going to look at the list of links. Okay, so for all intents and purposes, actually all this is a navigation controller embedded in the second tab with a table view in it. That's all it is. It's actually a table view controller. So let's look at that code and see what that does. The thing that I'm trying to accomplish is that I want each of my table view cells to have a link in it, right? And you may be wondering, how do you format a link in regular with regular UIKit classes? And the answer is you do it with UI Webview. So our class here is the list of links controller, okay, which is a UI Webview delegate. Actually, more about that in a moment. Let's just look at this class as it is right now, and I'll show you how that text is embedded, and then we can show you what we're going to do with it. So my table view controller is going to have just one section, okay, and I'm going to add 3 cells. Right, so there are 3 cells returned. I'm just hard coding it for now. And here's where we actually create the cells. So in our table view cell for row at index path, because we're good citizens, we dequeue reusable and try to see if there's a cell already there. And if not, we init and auto release. That's standard practice. But now down here, when we populate the cell, let's actually look at how we're formatting text. So I have this NS string variable, right? And for each of the rows, I'm going to set it up with a different link. In the first case, I'm going to set up a standard HTML. Ahref is how you do links in HTML. Ahref, and it'll link to Apple, and it has the text Apple. The second link, the second cell, is going to link to stanford.edu, and it's going to say Stanford as the name of the link. And the third row is going to be Disney, and we're going to go to Disney. So our HTML, what we're actually going to do is we're going to just create a string. It's going to say go to, and it's going to embed the link in there, which is the ahref with the name. And then we're going to pass that into a web view. So first thing we do is we create a web view here, UI Webview alloc, init with frame. In this case, I'm using the bounds of the content view of the cell. And we're going to, don't worry about this delegate right now. We'll talk about that in a moment. But here, we load the HTML string. So we're telling the web view to load this HTML string that we set up here, which says go to and then the link, no base URL, and then we add that web view to the content view.
People shouldn't do that though, because you're adding a new web view in the reuse case, so they're going to stack on top of each other.
Oh yeah, yeah. Josh brings up a good point. Is don't. Okay. The problem I have here. Does anybody want to guess what the problem I have here with web views? I'll tell you. Okay, so if we were to actually reuse these cells, we would continually be adding new web views to those cells. So if one of these cells gets pushed for reuse, the next time it comes back, we're going to stick a second web view inside there. So not a good idea, but for illustration purposes, good enough. So let's hit run and see what this does. Okay, so we're going to go to the second tab, which is the list of links. This you've seen is pretty familiar to you. List of links. Okay, so here's my string, go to Apple, formatted by the WebView. Now these are links. So if I click through, it's actually going to load in a WebView, right? But that WebView is really just that cell. It's no bigger than that, so I can actually load Apple's website, I can load Disney's website, I can load Stanford's website, and all of them are inline. Probably not what you want. So this is where we're going to use the delegate methods on UI WebView to do something a little cleaner. So again, here when we set up our WebView, we set ourselves as the delegate. And if you remember back in our header, we set the UI WebView delegate protocol on our class. And then I've conveniently already written the function that does what I want. But this is the should start load with request. Okay. Now, again, if you remember, this one returns a Boolean to say whether or not the WebView should follow through with that request. Yeah.
Do we also need to release the WebView from the?
That's a great point. So, yes, good. It was a test. You passed. WebView release. Good call. Okay. All right. So in should start load with request navigation type, we are going to check to see what kind of navigation type it is. If it's a link that was clicked, then instead of allowing that content to be loaded in the same WebView, which is in the cell, we're going to create a new WebView controller. And WebView controller is essentially what we showed in the earlier example. I'll show you that a little in more detail. We're going to set, so the request that comes in as part of this method has a URL associated with it. That's a property on NSURL request. We're going to set that as the URL for the WebView controller. And then we're going to tell our navigation controller to push the new WebView controller on its stack. And this time I remembered to release. Okay, now down at the bottom here, so if it was a link that was clicked, we're going to return no. So we're going to tell the WebView don't do the load. But otherwise, we're going to return yes. So let's hit run and see how this works now that we've uncommented this code. All right, so I go to list of links. I click on go to Apple. It actually pushes a new, it's ugly, but it pushes a new WebView onto the stack. And does it load? Oh, come on. There's a WebView there. It's not loading. So the question is, why am I returning no over here? The reason is, if I returned yes there, the request would actually load in the WebView that we were just being called on, that the click happened in. So in addition to doing the push, if I returned yes here, in addition to doing the push, that cell would actually load the content as well. Actually, let's look at this WebView controller and see what's going on. So, all right, so here's my WebView controller class. It has an address field, and it has a WebView, and it takes a URL. I have this load URL method, which does what we've seen before. So it creates a request from it, and it tells the WebView to load it. And actually, another thing I'm doing here is I'm telling the address field to set its text to be the URL, the string for the URL. Should return, this is if you type stuff into the address field. Oh, here's what I didn't do. So, okay, if you remember from our talk on UI view controllers, an appropriate time to actually load data is when a view is about to appear. Right? So what I forgot to actually uncomment here, I did the wrong thing here is, I'm never loading it, right? So I'm setting the URL on the WebView. I go back here. I'm setting the URL on the WebView controller. I'm pushing the WebView controller, but I'm never actually loading it. So what we need to make sure is when our view will appear is about to occur, or when our view will appear gets called, that's when we're going to do the load. So in this case, I say, if there is no URL, I'm actually going to load our class web page, cs183p.stanford.edu, and then we're going to call load URL, which creates the URL request. And and loads it into the web page. All right, let's just do that for now. So I hit run. Actually, you'll notice, so this first tab is just that Webview controller, which defaults to our class web page. I'll get back to that in a second. But back to our list of links, when I click through on Apple, it pushes, it loads the Apple in a web view in this ugly little embedded browser that I created. If I click on Stanford, it does the same thing. And of course, I can zoom in on any of these, and I can click through. There's a link, or I can go back. It's just the same view controller that we already looked at. And of course, because we return no, we're never actually loading in that web view. This web view is essentially untouched, right? It loaded the HTML that we sent it, but that's it. Another thing, actually, since we're on the class web page on this first tab, this is what I wanted to show you, the richness of the UI web view, is that we post our PDFs online. Let's actually click on one and see what we get. Here's our slides, right? This is the PDF. It's formatted properly. It's got all the standard iPhone formatting for PDFs. Everything looks like a page. You can zoom in and out, right? So this is Josh's lecture. Oops, it's a pretty empty slide. Look at that. Oh yeah, all the builds are there. So that's UI WebView. I mean, there's really not that much more to it. Pretty extensive functionality. You can do a lot of things with it, but pretty basic in terms of API. So now, let's go back to our slides.
Question about that.
Yeah.
Can you customize things like when they click on a PDF, whether it's going to open up a new window with a PDF? Like, do you know what's happening, or is it all encapsulated?
Right. So the question was, can you customize the behavior? So if somebody clicks on a PDF, can you do something different with that? And if you remember that should load request, you can override that. Take a look at what request URL came back. Maybe do something special if you see that the extension is .pdf. If you have your own PDF viewer or something like that. So yeah. All right. So I want to talk about CoreLocation. CoreLocation is a framework to manage location. There are two classes that are really interesting, a couple others that are you won't use as often. But the first one is clLocation. And clLocation represents a point and vector in the real world. So I'm at Stanford right now. I'm in the education building, and I'm walking very slowly in this direction. clLocation would represent that in terms of geo coordinates and a vector for speed and direction. There's clLocationManager. Right? clLocationManager is a manager in this framework that allows you to get the current location of the user. And we'll look at a little bit at what methods it uses to do that. CL heading's another interesting one. Probably won't use it as much. Useful if you're doing like nav, or there are a few apps on the store that will tell you what speed and direction you're going in. It's like a little odometer, speedometer kind of thing. So you could do that with CL heading. But one thing with CoreLocation is there's no UI in here. This is only for this is a data class. clLocation is a data class for location. clLocationManager is a way to get the current location. So how does it know, right? Is it stalking you? How does it know where you are? Is the government listening to your satellite signals? There's three different ways that it tries to determine your location. The first and obvious one that I'm sure all of you have heard of and are familiar with for location tracking is GPS. iPhone 3GS is the first one, I believe, that included a GPS? iPhone 3G? Yeah, iPhone 3G? OK. iPhone 3G included GPS, right, in the device. Pretty cool that these phones, I mean, now all of them have it, to be honest. But that these phones in your pocket have this, that are able to track you down to the meter where you are in space. But what happens if you don't have GPS? So you're on an iPod Touch, and you open up the Maps app. it will actually show you where you are. How does it know? It uses Wi-Fi, and there are a few companies that have actually, I don't know how they did it. I think they drove around with their vans and mapped out all of the Wi-Fi spots in like the US and Canada. And so when you're connected to a Wi-Fi station, it actually knows where you are because they did that mapping for you. And actually, here's an example of a flaw with this system. My sister lives in Calgary, Canada. I'm sure you all know Calgary, Canada, or Canada at least. She moved there from Toronto, and I was out visiting her last summer. And I had a device that didn't have GPS on it. And I opened up the Maps app because we wanted to find there's this restaurant that just opened up that she heard about. It wasn't far. We had to figure out how to get there. When I typed in for directions from the current location, it was like 2,600 miles away. Excuse me, kilometers, right? It's Canada. So, and the reason is because her AP, her base station, her airport base station, which used to be in Toronto, was now in Calgary, and they didn't do the remapping, so they thought she was still there. And that's how they do it. And anyway, so that's slightly less precise than GPS, but more precise than triangulation using the cell network. So if you're on a cell network with your phone, it could actually take a look at the signal strengths of all of the cell towers around you and base your location on that triangulation. So each one of these systems, it goes less accurate as you go down, right? So GPS is down to the meter. Wi-Fi is down to the, 50 meters or something, like 100 meters maybe. And then the cell network tracking, I don't know what the numbers are, but somewhere between 100 meters and a kilometer. But another interesting thing about this is the more accurate you want to be, the more power consumption, the more power it takes to power these subsystems. So clLocation, it's an object that represents a point in a vector in space in the real world. It has a few different properties here. So 2D coordinate, a altitude. The coordinate, by the way, is 2 double floating point values, and they actually represent the longitude and latitude in degrees, right? So I don't know where we are right now, but I don't know, 30 latitude and something. There are a couple of variables for horizontal accuracy and vertical accuracy. So the location that you get back, it'll tell you how accurate it thinks it is. Location accuracy is not a number, it's an enum. It's not a value, it's an enum. So it's an enum that gives you a few different types. I think accuracy down to the centimeter, accuracy down to the meter, accuracy down to the kilometer, and something above that. The clLocation will also tell you your course and your speed, so how fast you're moving in what direction. And it'll even let you calculate the distance from another location, right? So if Josh is over there, I'm over here, and Josh has a clLocation value, and I have a clLocation value, I can pass that in. I can call distance from location, and it'll say he's about 3 meters away in the northwest direction. clLocationManager, pretty simple class. This is your portal to getting location data from a device. Not really much here. There's, you can get the location value. You can set yourself up as a delegate. And the interesting methods down here are to start updating your location, stop updating your location. Start updating your heading and stop updating your heading. I may have left this off the slide by accident, but I think there's a horizontal accuracy value as well, so that you can say, let's say you're building some app where you want to know what country you're in. You can set the accuracy to be the tens of kilometers, so you don't have to actually activate the GPS when you ask it for its location. So it's smart that way. But if you told the location manager that you wanted it down to the centimeter, it'll turn on the GPS and do the best it can. A few delegate method callbacks that you might be interested in. So did update to location. So if you start updating location and then the phone moves, it will call you back as it moves some significant value. And actually, if you look here, there's a distance filter value. That's basically you saying, this is the granularity with which I care for these update requests. update callbacks. Did update heading, so if I change my direction and speed, it will call back with that. And if for some reason it can't get it, it'll give you an error callback as well. That's it for CoreLocation. I'm not even going to get into CL heading, not super important. clLocation, you'll deal with a little bit in Paparazzi 3, but what you're really going to deal with here is MapKit. And what MapKit is the, yes?
So we have three kind of sources for the location.
Right.
Can you specify from which source we get the location?
Right, so question is, can you specify, there are three different methods of getting location data from clLocationManager. Can you specify which one of those you use? And the answer is through the accuracy. Right, so when you tell the location manager, and I think it's a singleton, when you tell the location manager that you want it accurate within a meter, it will automatically go and use the GPS. It always tries to use the one that's most accurate for the accuracy that you ask for. Does that make sense? If you said that you don't care about accuracy beyond hundreds of kilometers or tens of kilometers, it won't even bother trying to use the GPS if it can fall back to a cell network. If you're on an iPod Touch, for example, which doesn't have a cell network, and you say I'm accurate to within tens of kilometers, it doesn't have the cell network to fall back on, so it will go to the Wi-Fi. So, and if let's say theoretically, Apple came out with a device that had only GPS, no Wi-Fi, it would fall back to that if that's all it had. So, yeah.
Is there a way to dynamically change that? Like,
The-
looking at a map from like a really far out view, and you say I only care about kilometers, and then I only care about centimeters.
Right. So, question is, can you change that? Can you change the accuracy? Yeah, you can. You can actually set the value on clLocationManager. I don't think. Let's say it's already figured out your value down to the meter, and you back it off to say tens of kilometers. I think it'll still tell you that your accuracy is down to the meter, and at some point it'll decide that that's invalid and back off the accuracy that it reports to you. Another thing actually about these, so I mentioned that each of these is more, is a bigger power consumption. So GPS consumes more power than Wi-Fi, which consumes more power than the cell. Another interesting thing is those are also in relation to the speed with which it can calculate the value. So it's really fast for it to figure out where you are in your cell network. It takes a little longer to figure out where it is in the Wi-Fi network, and it takes a little bit longer to figure out where you are in the GPS network. So that's why if you open up the Maps app on a phone, you actually see this big round circle around your location, and it's roughly right. But then as it figures out each of the things, so at first it figures out the cell location, then as it figures out the Wi-Fi, the circle gets a little smaller, and then as it figures out the GPS, the circle gets really, really small, and it knows where you are. Okay, so MapKit, API to display maps, helps you translate. There's a few different things it does. Helps you translate between a clLocation, which again is like 29.663 latitude and something longitude. It'll help you translate between that and a human readable address. There are support for annotations, and annotations are pins on a map. So if you want to plot out restaurants or friends' houses, whatever it is. And reverse geocoding. Excuse me. So reverse geocoding is, I think, pretty cool. It basically allows you to start with a location and turn that into an address or a country or a region. And that does it through some web services, which are all abstracted from you. You don't have to worry about. So mkMapView, there are a few classes we're going to go through. So you should pay attention to this. This is all in Paparazzi 3. There's about 5 classes that we care about. And I believe you'll need to use 4, if not 5 of them. But let's take you through. So the first one is mkMapView. It handles display of a map. It allows you to set the map to be either the map type, which is what we see here, or the satellite type, where it shows you the aerial photographs. And there's a third type, which is the hybrid type, where it shows you both, like the roads embedded on top of the map of the satellite. It allows for panning and zooming. So this is really just a UI scroll view. So all the same things you've seen with, your Paparazzi 2 photo project, Webview zooming, all stuff like that. It's the same kinds of things in here. It has support for annotations. Again, those are the pins that you want to drop. And it allows you to display user locations. So in this little diagram here, we've got the blue dot. That's automatically generated for us because we told the MapView to say, we told the MapView to show the user location. So here are some of the properties on it. You can set a region. All right, a region is the rectangle in geo-coordinate space that MapView will show you. And a center coordinate, again in geo-coordinate space. So you can, in this case, the geo-coordinate center corresponds to whatever San Jose's geo-coordinate center is, and the region is whatever that happens to be, maybe 200 kilometers in all directions. You can set the map type. Again, that's the hybrid map or satellite. You can add annotations, remove annotations. You can get an array of annotations, and we'll look at what those are in a minute. You can ask for the user location. You can't set the user location. And you can set yourself up as a delegate, and there's some interesting delegate methods that MapView gives you. Let's look at the MapView delegate. So the first set of methods that it can tell you about are the loading state of the map. So when the user first brings up mkMapView, the MapView will automatically start loading its location. You'll get called with a view will start loading. When it's done, it'll say view did finish loading, and if there's an error, it'll tell you that. There are also methods about region changes. So if your user is dragging around the rectangle, dragging around the center, is zooming in or zooming out, every time that happens, it's going to tell you about that as well. Like for example, if you're writing your own Yelp-ish app, and you want to show all the sushi restaurants on the map. So you get the region from the map view, you go to the internet to your special service, and you fetch all of the locations of all the sushi restaurants that fall in that region. If you then go and, your user then goes and pans, goes several, countries over, regions over, you can then get the new region and get all the sushi locations and plot those on the map. And three more delegate methods here that are interesting. Allow you to interact with annotations. All right. So the first one here is MapView view for annotation. All right. By default, if you add an annotation to a map, it will create an annotation view for you. You don't have to do this. However, if you do override this, you can do some custom things with it. I'm going to say more about that in a second. The second function here, the second method here, is the did add annotation views. So when a map adds a few annotation views, it'll call you and tell you that there are new ones that it just plotted, and it returns the array of views that it added since it last reported to you. So, why am I bringing this up is that this is interesting for you for Paparazzi 3. You may choose to override the view for annotation and return a custom MK annotation view. And if you do that, that's fine. You have to build that yourself, and we'll show you what the API looks like. But if you don't return that, if you don't implement that function at all, it will create MK annotation views for you, and then you have a chance to customize them in the did add annotation views method. The last one here is the annotation view callout accessory control tapped. All right. One of the things you can do with an MK annotation view is you can customize it by adding callouts. And a callout is, I wish I had a diagram. If you tap on a pin on a map, sometimes it has the little red arrow that indicates, same kind of arrow you see in some list views, that indicates if you tap on it that there's more information. So this will tell you if one of those accessory views is tapped. So MK annotation, I've been talking about that a little bit. It's not a class, it's a protocol. All right? And we'll look at some classes that do implement this protocol. And it's a very lightweight protocol. The advantage of this being a protocol is you can have your own data representations of objects and return locations and titles and subtitles so that they can be plotted on a map. I recently worked on a project where it was done in core data, and I didn't want to have to go and map every one of my objects to some new object, some new MK annotation object, just to plot them on a location, plot them on a map. I just used the objects themselves and then overrode the coordinate return method, the getter, and return the appropriate location. So it's a protocol. That's the important thing here. All right, MK Annotation View. This is what you're going to be either creating or not creating in your Paparazzi 3 assignment. But here are the methods that you can call. If you want to create your own, you can call init with annotation, and you'll notice it takes an ID, an object that implements the MK annotation protocol, and a reuse identifier. And you should be used to reuse identifiers from table views, right? So it does that same kind of reuse for you. There are also a few different things that you can override here. I left one out. There's image. So you can set an image. I believe that goes on the left-hand side of the callout, or it might be. It's the entire thing. Okay. All right. Okay. So the image is if you tap on a callout and you've set an image. Sorry. Yeah. If you set an image on an annotation view, when you tap on a pin, it replaces the pin.
It shows up on the map.
Oh, shows up on the map. That's pretty cool. I've never used it, but that's great. So yeah, maybe you'd want to, I don't know, put photos on a map. All right, so the other method, there's a method here that I call out, and a second one that I didn't, that I should have. There's a left callout accessory view. In fact, I just mislabeled the second one. There's no UI view called subtitle. There's a left callout accessory view, and there's a right callout accessory view. You can set those to be whatever views you want, and those are the little chevrons that you can tap on a callout. Any questions on this so far? Nope. Okay. Okay. There's also an object here called MK Placemark. All right. MK Placemark, it conforms to the MK annotation protocol, so you can use these as your annotations if you want. It's a convenience for holding data that maps a coordinate, a geolocation coordinate, to a human readable address. All right. And here's the init method. It takes a coordinate and it optionally takes a dictionary. And these dictionaries actually convert, if you're using an address book, which we're actually going to learn about in the next class on Tuesday, there are convenience methods for mapping from somebody's address in address book to an address dictionary. And the properties for that dictionary, the keys for that dictionary, are actually correspond to these somewhat cryptic properties of addresses: thoroughfare, sub-thoroughfare, locality, sub-locality, administrative area. I don't even know what administrative area we're in right now. But I can tell you that we're in the US and the country code is US. But anyway, if you were to translate a location object to an address dictionary, this is what it would actually spell out for you. So I think it's, thoroughfare is street and locality is town or district, and anyway. All right, user location. So another thing you can get off the map view is the user location. Now we talked about CoreLocation. This is a convenience on that. It's actually a special case of a MK annotation implementing protocol that you can get directly off the map view. So if you tell the map view that you want it to track user location, you can say, give me the user, you can say, I think it should track user location, something like that. Then you can say, give me the user location of the map view. It's automatically annotated for you. You don't need to do anything for that. But you can set the title and the subtitle, right? So if I tap on my location in a map, the little blue dot, I can programmatically set the title that comes up in the callout when you tap on that. And of course, you can get its location. You can find out if it's updating or if it's done updating. And the last class, actually, I want to show here is MK Reverse Geocoder. I'm going to get into some examples after this. But if you have a location in space, right? If I get my geolocation right here, right now, it's going to have some value, 29 dot blah, 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 and 44 latitude dot blah, blah, blah. I made that up. That's not really where we are. So I would get that value from CoreLocation, and then I can say, I can create a reverse geocoder and init with the coordinate and set myself as the delegate. Okay? I then tell reverse geocoder to go find out where I am. It will call us back with the placemark or an error, but the placemark's the interesting one here. That placemark will be filled out for you based on where you are. So if I parse that placemark and look inside, excuse me. Okay. If I did that on my phone right now, and I checked out what that placemark said, it would say, I'm at Stanford in Palo Alto in the US, and probably the street number 2. So let's do a little demo. Oh. Excuse me. All right, so I've already set some stuff up here. I have another tab here called Maps. Ooh, that gave away too much. Let's look at the main window nib. All right, so my Maps nib is actually represented in another nib. So I have this Maps tab here. And that Maps tab, let's look at the this object graph. I'm going to show it as a hierarchy here. You can see what I have. You'll notice my tab bar controller has 3 view controllers in it. One is the web view controller, which we've looked at. The other one is the list of links, which we've also looked at. And the third one is the map view controller. All right. And it has a class of map view controller. So let's go look at that. Oh, and you'll notice too that it has a nib of map view controller. I've created both of these ahead of time. So here's our map view controller class. You'll notice it has one IB outlet, which is the map view. Not going to worry about anything else right now. But we'll open the nib. And here it is right here. We have a toolbar up at the top again. It should be at the bottom. And it has one UI segmented control. Right? That UI segmented control lets me switch between map and satellite. And below that, it has a mkMapView. You'll notice that the map, oops, where did that go? So this UI segmented control, if I look at the targets, it's mapped to the files owner, the MapView controller's change type method. So whenever I click on this, it's going to call my change type, and then we can query it for the type. Another thing to note in this nib, if I click on the mkMapView, right, we set it up as the outlet for our view controller. That's it. So let's look at the code. In mkMapView controller, all of this is commented out. We're going to look at this a little bit later. But again, very simple, not much more complicated. In fact, less complicated, I would say, than the Webview was, the example before. In our dealloc, of course, because we had it as an IB outlet, we're going to make sure we release it. But here's the guts. If in this change type action, I know that the sender was a UI segmented control, so I'm going to cast that. I get the selected segment index from the segmented control, and then I have the index. And then I'm going to set the map type to just one-to-one correspond to the segmented indexes. We can take a look at what those map types are. In fact, probably worth noting mkMapType. Right, there's 3 values: standard, satellite, hybrid. Standard is the map view that we saw. Satellite's the overhead aerial view. Hybrid we can't even access because I only have 2 items in my segmented control, but that's the hybrid. All right, so let's just hit run, and what do we get? You'll notice as soon as it loads, I go into Maps. It's already loaded the map view. I don't need to do anything. It's centered out to the entire world. I can scroll around. I can zoom in. All right, let's see if we can find roughly where we are here. California. We're somewhere near Sunnyvale. We're somewhere near Redwood City. Hey, look, it even says Stanford. It said Stanford before it even said Palo Alto. Look at that. All right, cool. So that's roughly where we are. Now here, if I tap this UI segmented control, it's going to change to a satellite view, right? A couple lines of code. Now everything's satellite view. Of course, if I had a 3-step here, I could go to hybrid as well. Right? Pretty simple. So I'm going to show you how to add annotations now. Again, I went ahead and I did this ahead of time. I'm going to add a new action, which is the add annotations action. Let's get rid of this commenting. So what am I doing here? Well, I got these off Google. I didn't just guess. But these are coordinates for a spot in this is a coordinate for a spot in Italy. So we're going to create a dictionary. We're going to say that the country is Italy. And we're going to create a place mark with the coordinate we created above and the address dictionary that we created. We're going to add that to our map. All right, and then we're going to release, of course. Second coordinate is another one I looked up on Google Maps. We're going to set up an address, and we're going to create a new place mark with the second coordinate and this address dictionary, and we're going to add that annotation to the map. Now, we need to trigger this action, obviously, right? So let's go back to our nib, and let's take a button, and we'll just stick one in there. I'm going to make this type look like, because we called it add annotations, I'm just going to make this the add, and we're going to map that to our file zoner. So control, show them both on this tiny little screen. Control drag from the add button to our file zoner, and we're going to say add annotations. So not too difficult, no rocket science here, pretty simple. What happens is when we load, let's go to our Maps tab. And when I hit this plus button, it's going to call add annotation twice on the map view with the 2 locations that we just saw. So there they are, they just showed up. Now if I zoom in, this is way easier with an actual device. Oh, do that again. Add. Oh, did I do something bad? Let's see. NS Dictionary, that's fine. Bonus points if anybody finds my problem here. Strange. This actually, well, I don't know for sure, but let's try taking these out. Oh, I don't even know. Maybe I should just look at my debugger. Let's find out what's going on here. Let's run in the debugger. We'll know for sure. All right, so we just crashed. This is an exercise. Aha, okay, so our Placemark title has a problem. I wonder why. This actually worked earlier. Okay, well let's leave off the address for now. I think so. I tried this with a later version of the SDK. That aside, I don't know why this is going wrong, but essentially it's trying to create a title from the Placemark's address dictionary. What I was hoping it would do, what it should do, is when I tap on one of the pins that it puts down, it would actually put up a call out that says France or Italy. Again, I'm not sure why this is going wrong. Let's just say these are nil for now.
Probably worth mentioning that you could subclass mkPlacemark to override title and subtitle.
That's true. So we could, the other thing we could have done is subclass mkPlacemark and set the title as an IVAR and return that instead of using this to generate it for you. hopefully this just works. All right, so this is not crashing anymore. So when we zoom in, now if I tap on this, and it thinks we're in the United States because we don't have an address dictionary, which is completely wrong. Yeah. All right, so anyway, the zoom will go all the way into this pin. Notice we're going into Rome. Let's center this guy and zoom in a little more. Right in the middle is Rome. Let's go into satellite view. And anybody recognize this? Colosseum. Very good. All right, so let's zoom out. Go to the other one. Another pin which is not the United States, despite what is labeled. And I'll figure out what this is for the when we post this example, the sample code on the website. This is the one that should have been labeled France or Paris. So go all the way in. And anybody guess? Yeah, of course you know what that is. In fact, I think we just used this ad nauseum in the iPad intros, but there it is. That's the Eiffel Tower. So those are the if you want to write them down, those are geolocation coordinates for the Eiffel Tower and the Colosseum. All right, next thing I wanted to show is how to track user location. I have a new method here called find me. All right, we're going to just uncomment this out below. And let's look at what this actually does. So update user location, find me. What this action does is it gets the, let's set up our nib. So I'm going to set up a switch that you can turn on and turn off the tracking of geolocation. So here's my switch, I'm dragging it in, and then we're just going to set it up to have an action of find me on our MapView controller. All right, so now this ugly toolbar is our map toolbar. Please don't do this. All right, so find me. Again, it's going to assume that the sender is a UI switch, so it casts it. It checks to see if the control is on, and if it is, it tells the MapView to show the user location. If show user location is true, it will actually update to the user location. So it calls this other method up here. Now what update user location does is it gets the user location off the MapView, gets its coordinate, and then it tells the MapView to center itself around that coordinate. And the last thing it does here is it kicks off this reverse geocoder. Okay, so if we haven't already allocated a reverse geocoder, it allocates one and sets ourselves as the delegate. And then it tells the geocoder start, right? So at some point in the near future, we should get a callback that says it figured out what the address is. So here are the delegate methods for the reverse geocoder. So the error case I'm not going to worry about right now, but in the case that it actually returns something, I'm going to, it returns a MK Placemark, which has a title. And again, I don't know why this didn't work for Rome and Paris, but it generates the title based on the address dictionary. So essentially what the reverse geocoder did is it took the location and turned that into an address dictionary, right? The street name and city and country, etc. So we're going to take the title off the Placemark, and we're going to tell the MapView user location that its title is the title of that Placemark. So now, did I hook up my switch? I think I did. So this guy, all right, it's already hooked up. So it's going to call find me when I turn it on. It's actually going to call find me when I turn it off as well. So let's hit run. Also, don't forget, this guy is loading in the background. Anyway, that comes in at some point. I'll show you something else on the Webview after this that I forgot to show you. Oh, it's already on. But if I were to, the default state was on. But so it never actually called find me. But right now I turned it off, so I told the map to not show the user location. When I turned it on again, it should should find our location and put us somewhere in Cupertino. Sorry, in Palo Alto. I don't know why that's not working. I swear this worked on my home network. I wonder if it's related. Yeah?
How does that work in the simulator? Because you don't have access to GPS.
Right. So the question is, how does that work in a simulator? And
I think it just says you're in Cupertino.
yeah, I think so the simulator is supposed to just tell you that this is just the simulator tells you that you're in Cupertino. It tells you that you're at Apple, or it's supposed to. Yeah, if you did this on device, it would actually do the lookup and base it on GPS and stuff like that. Let's put a debug because I really don't want this part of the demo to fail. All right, so let's stop there. The map. Let me turn it back on. I'm not getting called. Oh, you know what? I think I know what happened. I set the, right. So there's two levels. You got to be careful of this sometimes. There's two levels at which you can set these actions. I set the action on the bar button item, which would work great for buttons, but we're not a button, we're a UI switch. So I need to click one more time. If you look at the inspector panel here, it says that right now we have the bar button item selected. I'm going to click one more time, and we're going to get to the switch. So it basically dives in. Now we have the switch. I'm going to set this to be find me. Even the best of us have our errors. In fact, I've had two today. Let's just hit run. Go over to map. Again, I didn't have the default set properly, but when I turn it on, it's trying to find us. It thinks it found us. It's probably putting us in Cupertino. Let's dive in. Yeah, it put us in Cupertino. And if you remember the call out, when I tap on this, it should turn that location into a street, address, city, etc. And we've set that as the title for the call out, so when I tap, it says it's 23208 Glenbrook Street, St. Clair, I don't know where that is. It's one of those side streets in Cupertino. Anyway, it does work on a device. So that's the MapKit stuff. Actually, the last thing I wanted to show you, any questions on MapKit? Yeah?
Where is it pulling all that address?
Yeah, question is, where does it pull the reverse geolocator stuff from? And it's some magical machine in the sky. I don't know, I think there's maybe Google's servers or someone. There's like, there are 2 or 3 companies that are like these giant map conglomerate companies, probably one of them. So. The last thing I want to show you is what you can do with this on your Webview controller on the start load and did finish load. So these were 2 callback methods from the UI Webview. What I'm going to do is I'm going to tell the UI application to set its network activity indicator to visible when you start and to invisible when it's done. And this is something you should really do if you're doing network activity. It's kind of the convention. But you'll notice up here in the status bar, when we're loading a URL, you get the little spinner. And when it's done, you know, the user knows that it's finished. And if I do that again, so if I go to http www, this one should be a little faster. I hit return, you'll see it spin for a moment, and then it'll stop when it's done loading. So spinning, spinning, done, right? Stanford, spinning, spinning, done. So whenever you're doing network activity, I would strongly recommend you do that so that your users know what's going on. I've had, there's one app I use very frequently, and I won't call it out, but they don't do that. And when you click through to a link and you don't know if it's loading or not, it's really frustrating. So set the network activity indicator so that the user knows what's going on. That's it. That's it. So thanks.
For more, please visit us at stanford.edu.